Welcome back, everyone. It is 1:15 Eastern Time, and I'm excited for the next session and would love for you to join me in introducing Kevin Lertwachara and Leda Chen, two of the co-authors, along with Sanjeev Dagia and Allison Kelly, on the very successful first edition Business Analytics Communicating with Numbers, which will have a new edition coming out in January, the second edition. And they're going to present innovative teaching and analytics applying the CRISP DM framework. And I am going to give controls to Kevin. So you can go ahead. And presenting.
Okay.
Welcome, guys.
Great. Thank you, everyone, for joining us today. Leda will start off our presentation today, and I'll start the presentation, and he can start. Go ahead, Leda.
Okay. All right. Thank you. Yeah, good afternoon. Thank you very much for attending our presentation. I'm Leda Chen, one of the authors of the book Business Analytics, Communicating with Numbers. All right. Next slide, please. Okay. So in this presentation, we are going to discuss how we use cases and the big data sets in teaching business analytics to provide students with a holistic view of the analytics process. So first, I just want to mention the definition of business analytics that we subscribe to when we teach this topic is that business analytics is the scientific process of transforming data into insights for the purpose of making better decisions. And over the last few years, we have seen many universities offering classes and new programs on business analytics, but also we are seeing some serious limitations on how those are being implemented. First, most of these courses are still being taught in the same way that business statistics courses are being taught traditionally, which is to focus heavily on the modeling phase without providing students with a comprehensive view of the entire analytics process, going from data to insights and then to decision, as described in the definition I just mentioned. And the second limitation we see is that most of the analytics programs tend to emphasize technical skill sets, such as programming, but often overlook other important aspects, such as problem formulation, data understanding, and the storytelling. So as a result, students are often ill-equipped to deal with real-life data and analytics projects. So through our experience teaching business analytics over many years, we have found that experiential learning approach is the most effective approach for applied and complex subjects such as business analytics. And to provide students with more structure in their learning experience, we usually use a widely accepted framework called the CRISP DM in our pedagogy. So on this slide, there is a citation for a teaching paper that we wrote about a term-long class project that incorporates the CRISP DM process. And the paper details how we use the CRISP DM framework in teaching a case, and also asks students to work on the project. And I will be happy to send you a copy of the paper. And so what is CRISP DM? Well, next slide, please. And so CRISP DM stands for Cross-Industry Standard Process for Data Mining. It was created jointly by 6 companies in analytics to help project managers navigate through complex data mining projects. As the diagram on this slide shows, CRISP DM is an iterative process that includes 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. But to make CRISP DM more conducive to the educational setting, we have developed specific learning objectives for each phase, which are listed on the left side of this slide. And I'll provide some more details here about each of these learning objectives. So in the business analytics project in our class, the project usually starts with business understanding, which requires the students to identify key business questions to ask that might lead to actionable business strategies. The data understanding phase requires students to understand the data from the business perspective, not the technical perspective. And through the use of summary statistics and visualizations, students would identify relevant variables and understand the data quality issues that may exist in the data set. The data preparation phase is a technical phase where students would develop a comprehensive plan for data wrangling, cleaning, reduction, and transformation to prepare the data for future analysis. And then the modeling phase is usually where the fun is, and students will develop various descriptive, predictive, and sometimes prescriptive models that assess and also assess the model performance. During the evaluation phase, the students would put on their business hat again to evaluate whether their analysis has achieved the business objectives they set out at the beginning of the project. So the students are encouraged to interview industry experts to help them develop compelling data stories at this point. And these data stories usually would lead to actionable business strategy.
So like Leda mentioned, that implementing the analysis findings could be difficult in a classroom setting. So what we emphasize in our classes would be to communicate key findings through storytelling and also with oral and written communication. And I'm gonna refer back to an earlier presentation today. I think most of you were there with Brian Hart, who put a lot of emphasis on translating technical into non-technical communications and not just focusing on technical answers, but getting to the business answers. So here, Leda is back. I'll let him talk about the data set he uses for his term project.
Okay, sorry, there was some network issues here. All right, yeah, thank you, Kevin. Yeah, so in our analytics class, we try to simulate real-life analytics through a term-long project with real data. And the data sets and the business problems usually come from real companies. But sometimes we also use a relatively large data set that's publicly available. And you can also use this data set if you want to replicate our experience in your class. And the entire process is documented in the teaching paper that I mentioned earlier. So the publicly available data set is the ERIM data set, which was made available by University of Chicago's Booth School of Business. And here's a link to the data set. And essentially the data set contains data about 3,000 households in 2 Midwestern cities and their purchases in a number of product categories over a period of 3 years. So here's the also the data dictionary of the data set, a part of the data dictionary. So as you can see, there's a lot of demographics variables as well as purchase history data. Okay. So the data set is relatively large and messy, which imitates the kind of real life data students tend to get at workplaces. Okay. The instructor can also scope the project in any way he or she wants. For example, you can assign each project team to focus on one product category only, or assigning the same product categories to all teams and let them compete for the best insights. And for students with different levels of technical background, you may choose to give them different versions of the data set with various levels of messiness. Right? And so students will start the project by gaining some good understanding of the business context surrounding the data and brainstorm some potential business questions they can answer through the project. And during the data understanding and the data preparation phase, we want to impress upon students the importance of obtaining summary statistics and visualize the data. And these activities help students get a better understanding of the data and identify any potential data quality problems. We also encourage students to develop a comprehensive plan for data wrangling to transform and enrich the data. For example, most of the original variables are probably not readily usable in analysis. For example, like date of birth and names of the male and the female head of households. However, with some transformation, they can be converted into variables such as age of the person and whether this is a married household or a single parent household, which are more useful in the analysis. Next slide, please. Yeah, and in the modeling phase of the CRISP-DM process, we usually divide it into two sub-phases, model development and the model evaluation. And during the model development phase, we try to impress upon students the strengths and the limitations of various modeling techniques. A number of modeling techniques, including the regression techniques, k-nearest neighbors, naive Bayes, decision trees, ensemble trees, neural networks are all considered. And another point we try to impress upon students is the differences between an explanatory model and the predictive model. And the students who come from a statistics background tend to be familiar with the explanatory model, which would help explain how the predictors impact the target variable. But in analytics, we are often more interested in how well the model would predict future outcomes, right? So, which means that its performance is based on the validation or the test data set rather than the data set that's used to develop the model. Right? And the students will find that a well-performing explanatory model may not necessarily predict future outcomes very well. Right? So students need to learn to balance between the explanatory power of the model and its simplicity and the predictive performance. And also, instead of using the goodness of fit measures that are often used in statistics, in analytics, we often ask students to use measures for predictive performance, such as accuracy, sensitivity, and specificity. And also, we ask them to use charts such as lift chart, decile-wise lift chart, and ROC curves, right, that are less sensitive to cutoff values to evaluate the model and compare different models. Right? So, at the end of the modeling phase, the students would have constructed a number of predictive models and selected their best performing model for answering their business questions. And on this slide, we have some examples of the models built using the ERIM model data. And for example, the regression model here it happens to offer both great explanatory power and predictive power in predicting consumer purchase behaviors. However, if we want to predict how much each household are likely to spend on various products, right, a simpler regression tree model turned out to be the best predictor, even though it provides very limited explanatory power. So of course, what's shown on this slide is not what we want the students to present to the executives at the end of the project. The students need to develop data stories using interesting and attractive data visualizations, and also use the language of business rather than the language of statistics or analytics for storytelling. And the narrative they present to the executives should answer these questions. Why should the decision makers care about the findings? How do these findings affect the business? And what actions do you recommend to the decision makers? Right. We often find that storytelling is a little bit intimidating to students that come with a technical mindset. But it's also an important career skills that can be developed and improved over time with practice. So that's a quick overview of how we infuse the CRISP-DM framework in our project-based teaching. And you can read more about it in the teaching paper I mentioned earlier. And the CRISP-DM framework not only can be used to structure complex analytics projects like what we do in this class, but also can be used to structure an entire course on business analytics. Next slide, please. So for example, in our textbook, Business Analytics Communicating with Numbers, we have fully incorporated the key features of CRISP-DM to help enhance teaching and learning. This slide shows how the book content corresponds to the phases of CRISP-DM. For example, we have an introductory chapter that discusses the business applications of analytics and how to formulate business problems and objectives. And each chapter comes with an introductory case and a big data case at the end of the chapter that would present real-world business problems and how to formulate analytics questions that would lead to actionable strategies. We have two chapters that are dedicated to data understanding and data preparation. And among them, one of the chapters is on data wrangling techniques, which in our view is one of the most important skills in business analytics, but is often overlooked by other books in this field. And for modeling, we have 7 chapters that are dedicated to different predictive and prescriptive techniques. And among them, we have 4 chapters that are dedicated to data mining and machine learning techniques. As I mentioned, all chapters comes with introductory case and end of chapter big data cases. Right? And all these cases would come with synopsis and sample reports that demonstrate how analytics findings can be communicated to decision makers in an engaging and non-technical manner through storytelling. So next, I'm going to hand over to Kevin to delve deeper into some of the key features of the book.
Thank you, Leda. I think I'll elaborate more on the storytelling part and the communication, since it was a big emphasis earlier this morning when we heard from Brian from the Catapult Sports Analytics. So when we teach our class on business analytics, we focus primarily on teaching students to communicate the findings and telling the stories that they see in the analysis. And our textbook allows us to do this in every chapter in 2 very distinctive ways, like Leda mentioned before. Each chapter opens with a case study that students can easily relate to, and I'll have an example in a little bit to show you one of these cases. And we continue with the same case in the examples in each chapter to show students how to solve a business problem. And then we show them 1 or 2 paragraphs in a written synopsis to answer the business questions that we posed earlier in the chapter. And then at the end of each chapter, we provide, we use a big data set that comes with our textbook and introduce another business problem. And here we show the students a longer written report, usually about 1 to 2 pages. And we also feel that students also need to learn how to present the analysis results in tables and charts properly. So we usually have those visualization components in the section that we call writing with big data as well. So those are the 2 key components that put a lot of emphasis on communication and storytelling in our book. And here's one example on from chapter 9, which focuses on supervised data mining. And it deals with a manager of a fitness center who has just posted an open house for potential members. And so now the manager wants to develop a data-driven strategy for to help select which open house attendees they should contact. So this is basically a classic classification problem, and we use the k-nearest neighbors technique to provide the answers here. And as you see here, we first describe the context of the business and explain the data sets available for the manager to perform the analysis. And at the bottom right of the screen, we show some relevant output from the k-nearest neighbors analysis. And in this case, it's a confusion matrix with a list of performance measures. And then here's an example of the synopsis that comes with the case, right? But in order to get there, we also show students detailed software instructions, both for Excel and for R. And for some chapters, we use an Excel add-in called Analytics Solver. So we show them the screenshot and the options and the software configuration that they need to do in order to get to the result. So this helps a lot because the instructors don't need to spend so much time in the classroom going through these step-by-step instructions. Students can follow these steps on their own quite easily. And in addition to these software instructions in a chapter, we also provide 2 appendix documents on getting started with R and getting started with Excel. So the instructors can choose to use either Excel or R in their classes. Some people choose to do both. So that's really up to each instructor's preferences. And as Leda mentioned earlier, we want the students to learn about data wrangling. And this is based on our teaching experience and also our experience working with industry partners, because their data scientists, their business analysts spend a lot of time, a good amount of work doing data wrangling before they even get to do the data modeling and analysis. So in this chapter, in chapter 2, we started out with key concepts on data management. And but the majority of this chapter is devoted to converting data into a more useful form. And we cover many topics such as binning, subsetting, how we should treat missing values and outliers, and a variety of data transformation techniques, including dummy variables, category scores, and category reductions. Those are just some of the examples. So here's an example from chapter 2. We want to show the students that even with just data wrangling, they can gain a lot of insights into the data and answer business problems. So here's an example from the Writing with Big Data section. Here's a data set. This is one of the big data sets that we provide with our book. This data file, I think, has about 20,000 records of sales reps working for computer companies. And we have variables that include how old they are, their gender, their personality tests results, also what we call Net Promoter Score, which is a measurement that the sales industry uses to assess customer loyalty, basically. And in this report, again, our objective is to show the students how to present and communicate the business answers to the manager, right? So this is one of those end of chapter cases that we provide. And after the students are familiar with data wrangling and data transformation, we also have a lot of chapters that the instructors can choose from as far as the modeling techniques go. So in addition to chapters on linear and logistic regression and on forecasting, we have a number of chapters that focus on data mining techniques. And these are the techniques that more and more companies are looking for in students. And we cover from the introductory topics, such as Euclidean distance and performance evaluation, to PCA and commonly taught topics in data mining, such as k-nearest neighbors, decision trees, cluster analysis, and association rules. And in each of these chapters, we provide a lot of hands-on exercise problems with data sets so that students can practice and do assignments on these topics as well. And we also learn from the past that we also need to be actively involved in developing online contents and other supporting materials. So all 4 of us have been engaged with McGraw-Hill and provide exercise templates and guidance when McGraw-Hill develops the online content, such as Connect. And whenever we can, we provide separate questions for each software application, one for Excel, one for R. And we also work on thinking about how students might do the calculation and do the analysis. For example, if the students do the routing in intermediate calculation steps differently from what we do, then we put in the system some tolerance limit so that the system can recognize the routing differences and can still score the students' work correctly. So we put a lot of time and effort in here. It's the online content for our book is not just an afterthought, but it's a very carefully thought out product that we put together. I guess we can spend a bit of time talking about how people might use our textbook for their classes, because we recognize that different programs, different colleges teach this class differently. So some people might approach this from a B-stat point of view and wanted to add some analytics flavor. So there's a chapter on inferences, probability, linear regression, but you can add a few topics related to data mining, analytics as well. Or if you have more time in your semester, you could approach this from a more holistic approach. So it depends on the background of the students coming in. And some universities also have a two-course sequence, and they've split the chapters in our book and teach them in 2 semesters. So that's possible. And Leda and I, and also Sanjeev and Allison, have used the book to teach both undergrad and graduate courses, and it has worked well for us so far. And we'll be happy to share with you our syllabus and other course materials as well. So let Harper know if you need anything. So here's one of the courses I have been teaching, like everyone else that has been teaching online and hybrid courses. So I teach an undergrad course, and I use a number of chapters from my own book. And McGraw-Hill has a list of online tools that my students like to use. So we use ebook. I recommend students to use a mobile app called Read Anywhere, so that they have the textbook on their phone while they're going through the hands-on example in the textbook on their laptop computer. And because we provide detailed software instructions, so students do the work ahead of time in asynchronous settings. And then when they come to the Zoom meeting real time, I can spend more of my time coaching them and teaching them how to interpret the results. And that's how we want to approach this class, right? We don't want to spend too much time in the class going through the step-by-step instructions. So that's one of the key features in our book. And McGraw-Hill has a lot of tools for instructors to use to sort of manage the grading, the grade book, and homework assignments as well. So I have been using this for over a year and a half, and students seem to like the tools that McGraw-Hill has put together for our book. And I think I'm going to turn the time over back to Leda, and like what Harper showed earlier, there's a second edition coming up, and Leda will talk more about the new features and the new topics that we have added.
Okay. Thank you, Kevin. Yeah, so after the publication of the first edition of the book last year, we have received some great reviews and adoption of the book. So currently we are finishing our work on the second edition of the book. The second edition of the book is going to be available for market in January next year. And it has many enhancements to the first edition based on instructor feedback. So here are just some of them. In our first edition, we focused mostly on descriptive and predictive analytics topics and have only one chapter on prescriptive analytics. And based on the feedback from some instructors, we have significantly expanded our coverage on the prescriptive analytics topics. So in the second edition, we now have 4 chapters that deal with prescriptive analytics topics, such as spreadsheet modeling, simulation, risk analysis, optimization using linear programming, and optimization using integer and nonlinear programming. So these chapters are designed for instructors who would like to have a decision science or operations management flavor in their analytics course. And the second major enhancement in the second edition is the more in-depth coverage on some of the popular topics based on how instructors used our book in the past. So for example, in the first edition, logistic regression was included as part of the regression technique chapter. But nowadays, we have seen that logistic regression being used widely in a wide range of applications, both in business and non-business fields. So we decided to dedicate an entire chapter to this important topic in the second edition. And also similarly, we have expanded our coverage on the popular data wrangling topics and the data visualization topics, including an appendix on how to perform data visualization using Tableau. We have also made some changes to the chapter sequence and making it easier for instructors to design their courses in a number of different ways. So as Kevin mentioned earlier, our book can be used in many different ways, as a one semester book or a two course sequence, right? So for example, you can easily design your course as a business statistics course with some analytics flavor using the earlier chapters of the book, right? Or a business analytics course that focuses on data mining, or a two-course sequence to delve deeper into the predictive and prescriptive analytics topics by using the later chapters of the book. Right? And also for an applied topics such as business analytics, hands-on components are very important. But also we believe that software tools should not get in the way of learning. And in the first edition, as Kevin mentioned, we use two software tools. First is the R, and the other is Excel with Analytics Solver. And R is free, it's open source, right? But Analytics Solver, which is adding to for Excel, costs about $25 for 6 months educational license. So following the suggestions from some instructors for 2E, we have made it possible for instructors to teach the entire book, pretty much all chapters, using just the Excel or R. Right? So Analytics Solver is still being covered in the book in the data mining chapters, but it's not going to be a problem for instructor if they don't get the software for their students. Okay? And so by doing this, we made the book more, teaching or the class more affordable for the instructor and the students. And also in the past, people had an issue with different versions of R. They may get different results from different versions of R. And we also found a solution to this problem. So now for the second edition, there's a line of code you add to your R program so that you will get consistent results across all different R versions, including any future versions of R. Okay. And finally, based on the experience from using the first edition, we have included additional and updated exercise problems in the second edition. For example, the reporting on the pandemic by CDC, World Health Organization, and the governments around the world have given us a rich source of data. And we're including some new exercises and cases that are relevant to the pandemic so that students can relate to these current events. Okay. And so these are just some of the enhancements we have implemented in 2E. And with that, I would like to thank all of you for attending our presentation and open the floor for any questions or comments.
It sounds like there's a question about sharing a link to the data set, the ERIM data sets. We can provide that. I don't know what the best way to do this. We could ask Harper.
Yeah, the link is in the PowerPoint slides we have here. Yeah, Harper, you can share the PowerPoint slides with the attendees.
Yeah,
right?
so the PowerPoint slides will be shared after with all of the recordings after the event. So everyone will have access. Anyone that's registered will have access to the PowerPoints and will have that link.
Yeah, and also as we mentioned during the presentation, we have a relatively clean version of the data set. If you're teaching MBA students or business students instead of more technical students, I'll be happy to share that cleaner version of the data set to you if you want to use this project.
I see a question about Python code. I believe McGraw-Hill provides a set of Python code examples in the instructor's resources page online. So I think you can contact Harper. If you don't have access to McGraw-Hill Connect, you should contact Harper to set up your account there, and then you can see everything that we provide, including the Python codes.
Yeah. And also one thing I always emphasize, sorry.
No, go
Awesome.
ahead.
Yeah, one thing I always emphasize in my class when I teach business analytics is that you can use pretty much any tool. All the concepts we discuss in our book, in our class, can be applied to pretty much any tool. And once you know how to do it in one tool, the same skill set can be applied to many other tools. So we usually don't try to make our course to be too tool dependent. And sometimes in my class, I show them how to do the same thing in Python, in SAS sometimes. And students, they never know what kind of tool they will be using when they go to work, right? So, but they realize that once they understand the concept, it can be easily applied, transferable to pretty much any tool.
Thank you. So yeah, and within the Jagia business analytics text, there is the Excel as well as code example or R examples, and the Python supplement that Kevin referred to is a separate booklet, but it handles the exercises the same way the R and the Excel are. They're just in a separate booklet for Python. So that is something that's absolutely available within Connect, and we can get you access, and you'll be up and running with it. So thank you so much, Leda and Kevin, for presenting today. It was really informative and an excellent presentation.
Thank you.
Thank you, everyone.